I didn't hear that, but okay. So what we want to do right now is we want to go to the clinic. Well, we want to go to the clinic object, and we want to give it. We want to fill in a yoke. We want to put in. We want to put in some substance to it. So, ladies and gentlemen, in order to do this, we're now going to be in the realm of process modeling. We want to characterize the resources that are going to be limited, because Dr. McDonald's and Dr. Sternberg's time is limited, and people who see them will sometimes have to wait. Okay? So I'd like you to go to the process modeling library within AnyLog. And we're going to have to find this here from the set of options here. So there it is, process modeling, way up to the top. Thank you very much. Okay. Okay, so ladies and gentlemen, this is going to present us with a list of operators, a list of elements that we're going to string together to define a process. And I wish I had time to talk about all of them, but we're going to drag one called enter into here, okay? This enter. And it's going to be called Walkins, okay? Walk-ins. And we're going to string these operators together to form a simple process. And we're not going to do it in the most sophisticated way or the most concise way. We'll do it in a way that makes use of some basic operators that each have clear meaning rather than trying to combine them. Okay? So I'm going to define an entry point here where people will walk in. There's a TA help here? TA help needed? I thought, was there TA help needed? Yeah. Okay. So folks, so we dragged in a walk-in, and another thing we're going to do is we're going to add a resource pool. Okay. Okay, so this is in the palette. It's the top item of the palette. Process modeling library.
Some people may have their library entirely in the palette highly closed. So if you don't find that, go to the bottom left side. You'll see a plus sign. And click on the plus sign.
Okay.
And sometimes even when it's open, you need to look for the little carrots that says blocks and to expand that. And that may be hiding.
So folks, again, what she's referring to is I pulled this up earlier, and there's a list here. In this case, it's the top one. You could spot it here up at the top of it. But there are times where within these things there's something like this. It's collapsed down, and you have to open it up in order to see all the options. Okay? Okay. So folks, we've added an entry point, and we're adding a resource pool, which is going to reflect our staff. And we're going to call this healthcare workers. Okay? It's going to be generic, and it's going to be of size 1 initially, so capacity of 1, okay? Here we are going to connect to, we're going to add in a new action that's going to be the seize action. And this is going to reflect the fact that when someone presents for care, there's going to have to be a healthcare worker allocated to them, reserved for them. And we call that seize. They're going to and unfortunately it has a somewhat transgressive feel, but to seize a healthcare worker. And so they're going to seize this resource. They're going to be allocated the resource, reserve the resource. It doesn't necessarily mean immediately they're in physical proximity. They could be at some distance, but conceptually it's going to be allocated for them. So we're going to add in this component called seize.
Can you repeat that step, please? How to get to the seize?
Sure. Okay. So I will eliminate this. We had a Walkins before, right?
Your walk-in is of a certain type? Is it
Well, yeah, I had indicated to pull in an enter action.
as in,
No.
you define the agent type?
Yeah, we could define it to be an agent type, sure. We could define it to be a person who's going to be flowing through it. That would be a fine thing to do. We don't have to for our needs, but we could, okay? Okay, the second thing you could do, since you have this walk-in, I'd set the agent type to be person here, folks, per Sankalp's suggestion. For the walk-ins, I decided, okay, sure, we'll do it as person. It's a good best practice to do that if you're sure it's going to be persons, because it allows you to deal with them very clearly as persons. So you can ask about the person-specific attributes, so sure. And then I'm going to drag in an enter action. Oh, sorry, not an enter. What am I doing? A seize action. We had it earlier, but I deleted it for show. So I drag that in from here, and you'll notice if it's close enough to Walkins, it will keep it connected by default, which is convenient. Otherwise, I have to go drag and connect it up. So I'm going to put it like this, and I'm going to say, you know, assign healthcare worker, something along those lines. Okay, so they need to get and the point is that if that's not available, if there's no healthcare worker available for them, what are they going to do? They're going to wait. They're going to be queued up, awaiting the availability of this nurse or clinician, nurse or doctor, or what have you. Okay, that's great. We're going to here have this associated with a resource set, okay, and it's going to be healthcare workers, and it's going to be one of them. See that? Do people see that? So when we have this indicated, it needs to know some information in order to do its job. In order to be set up properly, it needs to know, well, out of what pool will I be allocating people? And I just use this plus button. I'll delete this so you can see how I did this. I'm going to delete it, and then I'll do it again. Ready? So when I've got this selected, I do the plus. I select the resource pool, and I indicate just one of them is needed. Okay? And there's some questions which don't apply so much to mine. I'm going to say a maximum queue capacity here. I'm not going to be too particular. But we may examine the impact later of going and simulating balking. So in other words, individuals who go on without having been, if they can't get a resource within a certain time, they leave. Okay? Okay, that's great. Now I'd like you to add an additional block here, folks. By the way, this agent type is again person down at the bottom of C's. It should be person. Do you see that? Are people okay with that? Who needs help? Okay. So Dylan, behind you.
Which one?
Asteria, I think. Okay. Who else needs help? Help? No? This is the very bottom of it. I did maximum queue capacity, yeah.
there's an option above that that says sees both set at once or one by one.
Yeah. So, well, if here, so this doesn't really apply to this case. If I specify different units that I need, maybe I need a bed and I need a clinician, I need a procedure room. Maybe I'll need each of them, but maybe only one's available right now. And maybe I'll seize that now and then I'll wait. Or maybe I just say, look, if all are not available, I'm not going to seize any of them. I'm going to wait until all are available at the same time. And that can be a very important issue, particularly with the terms of deadlock, this risk that I'll seize resource A, you seize resource B, you need A to do your job, I need B to do my job, and we're stuck, which is a classic issue when dealing with locking. Okay, are people okay to go on, or do you need help? Okay, so we're a lot of the way done with this, but let's continue to go on. So folks, there's a delay block. I'd like you to add a delay block. And this is actually going to be associated with the treatment conferred. And it's an unfortunate way to name it. So I'm going to say treatment. Okay? Okay, and for this delay block, I am going to take time, and you'll notice it says delay time is triangular. Okay? Now, I'm going to actually set it to take minutes, and I'm going to say it's 30, a minimum of 30, a mean of 45, or a sort of mode of 45, and a maximum of 60. Okay? Now, by the way, in AnyLog, this is a good thing to know about. Another way I could have specified it was in minutes is left this in the natural time unit of the model, and I could have said times minutes. And that's a really nice way to sort of indicate this if I had left this as say, the normal time unit of the model. But I can actually, very nicely, AnyLog has put in this mechanism for specifying things in different time units. This is an AnyLog 7 thing, and it's really admirable. It makes it clearer. Nicely declarative. Okay, so this is a delay time of triangular. You'll notice again this convention that it puts in bold the things that have changed. And that's good to know, to sort of see what I've changed. I'll say it's sure maximum capacity once again. And again, the agent type is person. Yes, Uncle.
So why is the agent type automatically changed in the assigned healthcare thing or the treatment?
I mean, why is it no that it's this?
Yeah.
I imagine it's because I've connected them via these connectors to something where I already changed it, and so it's just extra intelligent.
We're trying to seize a healthcare worker. So shouldn't the agent type be the same as the agent type of the healthcare worker? No. The type associated with this, this is the agent type, the type of the entity that's flowing through it. Okay.
Yeah. It's a good question about the, there is another individual involved, but that's at this point, just sort of a resource. It's not an agent. That's not what's referred to by that agent type. Okay, so there's a treatment, and that treatment is going to require a certain amount of time. Why is it important how long that requires? Why is it important how long that treatment takes? Anyone? At a conceptual level. What's that? Yeah, it affects the throughput. It affects my ability to serve people. If that's longer, what will be bigger then? What will be deeper? What will be longer? The queue will tend to be longer. People will have to wait for longer because each one takes longer, and therefore they're going to sort of stack up waiting for themselves to be served. Okay? Yes? So 30, 45, and 60, and I said minutes here. And what is this? Sorry? What's the semantics of it? What's the meaning? This is the minimum, 30, the maximum is 60, and the mode, the most likely value is 45. The triangular distribution it exhibits strong differences in how frequently it's used in different fields. But basically, this represents a distribution. It's a peak distribution. In this case, this is at 45, the mode. The minimum is 30, the maximum is 60. Yeah, but it needn't be symmetric.
The signature is actually min-max mode, so I think 60 is really.
Oh, it's min-max mode?
Yeah, we just took a look at the documentation for that.
Whoa. Hold on. Okay, that really shakes me if that's the case.
Do you want to throw in just another?
Yeah, let's throw another one in. That would be most interesting. Okay, so I'm going to throw another delay in here, and
Interesting. Yeah, so like I said, we just checked autocomplete, and it looks like variables are used.
okay, maybe you could talk with Anatoly about this,
Interesting. Okay, well, yeah, if that's the way it is, if it's min.
because this has been this way since I was tempted to say time immemorial, but it's been this way for years. Dylan? Yeah, you're right. It does say that in the documentation, but I think that's not correct. I think it's min mode max.
Yeah, it is.
Okay.
That's, it should have been fixed in the documentation, but it wasn't.
Yeah.
You know, there's a
Yeah, there's a
distribution
distribution wizard up
wizard,
there.
Yeah. So
Yeah.
It's
And it's probably specified correctly there, right? With this, and you could have a triangular, and here's the min-max mode. And so if we inserted that, then it will be inserting it.
you insert it in the middle of.
Yeah. Okay, but it looks like it inserted it with it reversed, because 525.15, and then it inserted it 525.15.
Oh, really? I will write it down.
Yeah, I think. Thanks a lot, Anatoly. I really appreciate you. It's min mode max. Well, I mean, I've used this for years, and Anatoly has used it for even more years, and I'm virtually certain it's this. Anatoly, you're pretty certain also it's min mode max. Is that right? Yeah. Well, in any case, we could always test it. You could have a loop and generate it and see. But you would think it would cause an error. It would say like, oh, you've specified illegal values here. Yeah. So I think it would show immediately. Okay. So anyway, thank you, Dylan, for spotting that issue.
The delay we put in, is that to sort of add a random delay in assigning healthcare workers?
No, this is associated with, look, there's some work to be done by, this assigned healthcare worker is going to grab a resource. And if there's one immediately available, we grab it immediately. If there's one that, for which we have to wait, we will wait until it's available. But then there's some treatment to be offered by that individual. So Jeff has to do a workup. And he may have to take a history, of this patient. You may have to work through some diagnosis. Yeah. Okay. So here's the treatment, and then following the treatment, we're going to actually release this. This sounds unpleasant again, but release the healthcare worker. So release healthcare worker. Healthcare worker. Okay. So you're going to release them, and this is going to be, and we could say, okay, if it's something we've seized that is moving, they can return to their home location. And we don't have time to go into a visual example of this, but we could have someone circulating, a clinician, and have them move around and then move back to their home location. We're not doing that here, so but you should be aware it's very readily doable, and you'll find lectures by me online where I show some aspects of how this is done. Yeah.
Sorry, why is the healthcare worker being released? I thought we were dealing with the
Okay, so this is a good question. I mean, fundamentally what's happening is that, I'm gonna stop this. I don't want to, well, maybe I'll just say, okay, so fundamentally you have agents presenting for care here, and these agents are flowing through this system. And for each step of the system, they are potentially being processed by the system for that step. So for example, this first step, they're assigned a healthcare worker. For the second, they're conferred treatment. For the third, they're released from that healthcare worker. The healthcare worker is no longer reserved for them. They're allocated to someone. They can be allocated to someone else. That allocation is complete. So for each of these stages, you have an entity flowing through. This kind of agent is presented for care. And they'll be queuing if the resources required to undertake that particular stage are not available. So they will be waiting. And so when you specify these operators, you are doing so with an entity in mind, but you're stating the resources that are required for that entity to be processed. So here, if an entity reaches this point, they are allocated a healthcare worker, and they will not proceed until one's available. Having been allocated that healthcare worker, they will then proceed to treatment. Undergoing treatment by that healthcare worker. Undergoing workup, your history being taken, a physical being done, etc., and some diagnosis being made, you will then transition on to the state where you are done with your clinical involvement and you will be released. And one thing that's going to be happening here is that we're going to enrich this flow, and I probably should have anticipated it right now. Right, okay. So we missed one block, and we need one more block here, and that is a choose block, okay? So over here on the left-hand side, there should be a choose. So where is it here? Okay, seize, move. Okay, do you see it here? Okay, so resource and maybe it's called now select output. Okay, maybe they've changed the name of it. That.
Are you looking to choose between one of two things?
Yes.
Yeah, that's what I know.
Okay, so it's changed the name, I guess. Yeah. You think so? Okay. So this is determine outcome, determine clinical outcome. Okay.
Which one, what operator is that?
It's called select output. Yeah. Select output, not select output 5, which has 5 options, but select output. Okay. So there'll be 2 different options here. One option will be that a cure is actually successful, and one where it's unsuccessful. Okay? So now we are going to take this, and both of these are going to lead on to a situation where we can connect to the to downstream, but in one case it will have failed, in one case it will have succeeded. So I'd like you with this select output with a probability 0.95. In that case, we will then undertake an action, and guess what this action will be? We'll treat it as being cured with probability 0.95. Word only so. And what will happen when there's a cure conferred? We send a message to whom? Good. Now you'll notice again there's this.
Do you want to be on exit true if you're doing?
Yes, it's for this one here. Yeah, not the on enter. So Here this says, okay, there's two options available, self to refer to this or to refer to the agent. So here we could say agent dot, okay, and because this is a person, this is going to, we're going to be able to send them a message. We could actually ask what state they're in, etc. In this case, we're going to simply send them a message, okay? And we could say, okay, we're going to send a message. What message will we send? Cured. And to whom will we send it? To the agent, right? Okay, so we're going to send a message to an agent, a destination. So the person receiving it will be the current agent. Okay, and we're going to now just have the other way. They won't be cured, and we won't send any message. Okay, so having done that, that's one path. In other words, this is the path of successful treatment. For the other path, where the treatment was unsuccessful, we don't send a message at all. Great. So we will now take this, and we're going to want to add a new transition in here. So I'm going to, for convenience, I've double-clicked on this transition and dragged it over so I can have a bit of space here. And I'm going to copy it, and I'm going to paste it, and I'm going to drag another transition between them, which is going to represent unsuccessful treatment. So we have two routes basically from this person, from this point onwards. One route, which is if it's successful, and one route if it's unsuccessful. This route being successful is associated with a cure, and the other route, which is unsuccessful, is associated with a treatment failure, in which case nothing is sent. So this one will be called cure. We're just going to call it cure, and this one will be called treatment failure. Okay, treatment failure. Okay, and then following that, we're going to release the healthcare worker, and at that point, what's going to happen? We'll be able to go home, right? Okay. So we're going to release the healthcare worker, and then we're going to have an exit block, and that's going to be that's going to allow people to leave the facility. So here's an exit block, and this will be called departure. Okay? Great. And what needs to happen at departure? Okay? Folks, what needs to happen at departure for them to be able to go home? Okay, they're going to exit, but what needs to happen at that point for them to go home? Let's look back. Who are these people flowing through here? These are people, right? They're described by what class? Person. Okay, if they're at this clinic, if they're under care, under what situation will they be able to go home? If they're sent a message, right? Departed healthcare facility. So that's what we want to do. In that final stage, we need to send them this message saying that they're free to go home that they depart the healthcare facility. That allows them to go home. So we could say agent.send, and we send this message to that agent. Okay, we're having them send themselves this message. Now, I have what's called a hanging connector. Oh, I just copied that and didn't get rid of it. Okay, I'm sorry. Show you the bend. This thing? Yeah, all I did is, I'll show it again. I double clicked on it, and that allows you to bend it. and same thing with this one, I had double clicked and I bent it. The departure was from the exit item of the palette. So in this on exit, you do this. Yes.
So why don't we use self instead of the agent?
We could.
Oh,
We could. Self would be, okay, so the clinic would send them this message saying they depart. Yeah, I think that's okay. Sure, we could have self dot send. Yeah, we could do that. It seems a little bit weird to me to think about a clinic sending them this message, rather they sort of choose to leave the healthcare facility, but I don't feel strongly about it one way or the other.
Sorry, I understand what you're getting at, but is there a situation where the clinic will confuse the order of the agents? Or is it just going to be referring to the agent being processed?
It's the agent being processed.
Okay.
That's the trick with these sorts of process modeling things. You're referring to the agent being processed, and when an agent gets here, this code will run for them with this name being the agent. Okay? Okay, who needs help here?
Can you explain how to change the transition,
This thing?
the message? Yes. that one.
Sorry, the message?
Yeah, the transition from after leaving treatment.
Yeah?
Yeah, there are the two messages, the two conditions.
Yeah?
Can you repeat that? How to?
Okay,
change that?
maybe I'll show it to you. Here you go. So select true output with probability 0.95, and for that true thing, they're setting that. Maybe we should say self dot. So if you want, we could have the clinic say they're cured. I guess that's okay. I don't feel strongly about it. Who should be saying they're cured? But sure, maybe it's the clinic that sends them a message. Sure. Okay. So with 95% probability they'll be cured. Otherwise, nothing will happen to them.
Logically speaking, should we put another hours processing and reassess or something? As in, otherwise you sunk them. As not cured means they've died and they've stayed in hospital.
No, they don't stay in hospital. They go home, but they aren't cured, so they'll represent. They'll come back because their health state isn't resolved.
Okay.
You see what I mean? Because remember, in the person, we have a distinction. This is very important, folks. What happens, people, maybe as a motivation for understanding this, what happens if someone goes to the clinic, they flow through, treatment is conferred to them, but that treatment exhibits treatment failure? What happens? Are they going to go home? They're going to go home. Why are they going home? They're going home because they reach the end of this progression. Either way, they're releasing the healthcare worker, they're going to depart, and they're going to be sent, as part of the departure, they're going to be sending a message that says departed healthcare facility. So they're going home, but what's going to be different between them and a person whose treatment is successful? What's going to be different between them and a person for whom the treatment is successful? They'll still be ill, and guess what will happen if they're ill? Guess what will happen soon? They'll come back to the facility. Come back within, probably on average within 20 days. Back to the healthcare facility. They'll represent if it isn't successful. So the fact is, we only send them a message saying cured if the treatment is successful. And over what transition will they travel when that cured message is received? Over what transition here? Yeah, they'll go over this transition here, and that will lead them to be healthy. Since they're healthy, will they present for care within 20 days on average? No. Now they're going to be cured there. Dr. McDonald's done a good job. Yes.
I have a question. If you can go back to clinic.
Back to what?
If you can go back to clinic.
To clinic, yeah.
Where you made that select output thing.
Yeah.
If you were wanting to do another action.
Yeah.
For people who are sick or something, is there a way to determine which one goes to release healthcare worker and which one goes somewhere else?
Oh yeah. Yeah, so one of these, I think it's this one is the one if it's true, this one is the one if it's false.
Okay.
Yeah. And so one will go one way, one will go.
Is there a way to know that? Because it doesn't seem to say.
Yeah, I think it's in the documentation for the library for it. And there's a broader one called Select 5 where you have 5 outputs. 1, 2, 3, 4, 5. Okay? But I think this is kind of the true case and this is the false case. Yeah. Okay, any other question? Yes?
More question for, are they going to bring back the labels? They were really helpful.
The old labels, you mean like the T and the P, and I'd like those. I know. I really like those labels too. Yeah, Anatoly, any chance they could bring back the labels or?
I don't think so. New trend, minimalistic design, so like Windows 8,
Okay, but could you have them appear if you hold down Control or something? Or hover?
It has been discussed several times internally. I will pass this request. You'll get it back.
Okay, yeah, I do think the hover idea is a good one. I do think the hover idea is a good one, like if you hover over it.
We talked about that as well, and everybody agreed that should look good, not overwhelming all these canvas. Yeah, but I don't know whether it will be implemented. I can check that.
Okay, that would be great. Thanks a lot. That would be really good. Okay, folks, I'd like you to do one more thing with this. We're almost done with this example, but we're going to put in balking behavior. Okay? Should we run it first though and see what happens? What do you think? Run or not? Run. Okay. Okay, so let's run this. Ready? Okay. What should we see that's different now? Ask yourselves before you run model, what do I expect? That can help you learn more quickly because you'll spot things that didn't align with your mental model. Okay, so here are people, they're presenting for clinic, or they're ill, and they're presenting at the clinic. Let's go down to one of these clinics. Okay, here's clinic 0. This one is got the healthcare workers waiting at the back of the room. Okay, clinic 1 and clinic 2. Okay, we haven't connected them. We forgot the key step. Okay, so what's the key step here? You have to walk in. So the key transition is going to occur where here? So they go to the clinic physically, but they're not part of the process. Where do they need to be part of the process? What's the key nexus? Okay, you said under care, and it's entering under care, right? So this is the reason I had that nearest clinic variable. There wasn't any other need for it then, but there is now. Guess what? Now we need to know what clinic they're at. right? Before we had nearest clinic and they were going to the nearest clinic. Okay, well, no problemo. Let's go. How would we do this?
But if you still said the same thing, if you said nearest clinic.
Is that true?
It would be, if they are there.
How if there's two clinics at exactly the same location?
Yes.
How if a new clinic has appeared at that location in the meantime?
Yeah, but if it sent you there, then that is going to be your nearest clinic.
No, but a new clinic might have occurred while you were coming. Believe me, we software engineers have to face this every day, and wishful thinking is not part of what's acceptable. But what we can do is we can assign a variable at the time that they determine it that will then be used when they get there. That is safe. That is safe. Okay. Yes.
Valuable anyway because you may be deterministic and say you need to go to this clinic for that reason because the service
Good.
is otherwise not available.
Good. Good. Okay, so I like that idea. So here, folks, we're gonna have to elaborate this slightly. We're gonna need to go and get a variable, and it's gonna be called destination clinic. It's not just the nearest. It'll be determined on the fly. This is the difference from the old system. But having been determined when we get there, we know what clinic we're at. We're not going to say, what's my nearest clinic again? Which may no longer be my nearest or something. Okay, so destination clinic. What sort of type is it going to be? It's going to be a clinic. And where are we going to set it? In that transition. So, yes, in that transition, it's exactly right. We're going to, instead of just going move to nearest clinic, we're first going to set the destination clinic. This is going to help us remember which clinic we're moving, and then we're going to have to move to there. Okay, so that's good. And then where can we use that information? When we enter under care. So let me put this up on the big screen here. Boom. Okay, so this combines the best of Sankalp's idea and the best of this idea of a dynamic computing of the clinic that Xiaowen had advanced earlier, which is a very powerful idea and one having to do with resilience, which is I think close to Roberto's heart. Yeah. Okay, so what do? We added a variable called what? Destination clinic. Here it is. It's of what type? Clinic. Having added that, we went to this transition from not seeking care to in transit, and we assigned to that variable getting the nearest clinic in main.clinics. And then we move to that destination clinic. Okay? And having moved to there, when we reach this point of under care, as Sankalp suggested, what are we going to do? We're going to present for care at that clinic. And so what are we going to do? We're going to say destination clinic dot what? Destination clinic. We have to actually tell it we want to enroll in this clinic. And the way to do this is you say take. Destination clinic take. Hey. Okay, now I'm clinic dot take. And who do we take? Take myself. This. It's me. It's me. Take me in. Okay? Okay, take person. Oh, okay. Oh, great. Sorry? Oh, it's under Walkins. Thank you. It's called Walkins. Yeah. It's that particular piece of the destination clinic. Thank you. Yes. It's not the clinic as a whole. It's this. Where did this Walkins come from? Where did that come from? Yeah, this is the in the clinic, it's this thing here. That's the entry point. Because maybe clinic has several doors. You know, there's a door for people who are walk-in and a door for people with appointments or something like that. You can go in that way or you can go in this way. Okay? Is that okay? Sorry? What was that?
On the transition destination on Can It Get Nearest, what was the end of that code?
This one that was located here, I think.
Yeah, that's it.
Yeah. So this is what that was. This is the code for when entering under care state, and this is the one for the transition to in transit to care. Transit to care. Is that okay? Oh, thank you. Thanks, yeah. Thanks. Boom. Great. Okay, so that's when entering the undercare state, you're going to say, take, hey, the Walkins area, take me. And for the transition to in transit to care, at that point, we're going to set our we're going to find our destination clinic. We're going to remember it. What is this destination clinic? That's referring to a what? To a variable that we added of type clinic. Remember that? And then having determined that, we're going to move to it. So as Shawan suggested, we are determining our destination dynamically, but we remember our destination, so when we get there, we know in what clinic to enter, because there could be two on top of each other. Well, although unlikely though that is, I didn't want to leave anything to chance. Okay, how many people want me to keep this up there for longer? Okay? Yeah, the previous line being? Right, yeah. We broke it into two lines. The first gets the, that's right. So now we just do that now. Yeah. Okay? Okay, who needs help? Okay, where are walk-ins, folks? From whence does that walk-ins come? Where are the walk-ins from? This reference to walk-ins. It's in clinic, and where is it in clinic? It's this guy here. It's the entry point to that process. And it's conceivable that we could have multiple entry points, one being for people with appointments, one being for people who are walk-ins, one being for people who are emergency patients. And we could route person to each of those points by referring to, you know, emergency entrance or appointment entrance, you know, that sort of thing. Does that make sense? Okay, who else needs help? Oh, yeah, sorry. Yeah. Okay, so this is the variable. We're setting it. We're determining to what clinic we're going to head. We're setting it, and we're going there. And then when we get there, we're going to put ourselves inside of it. Yeah. Is this the entry action? It's the entry action of undercare. Yeah. Yeah.
Given your logic,
yeah.
This simulation should never end, right? Because eventually when you become healthy,
yeah,
you will decay into that state.
That's correct, exactly.
The simulation ends.
Well, but maybe it's set. Okay, we'll get to that, Sankalpa. It's a good question, and there's another reason for that. Okay. Okay. So folks, Hayden.
It's just an error. Can't work out where it's coming from. It's not liking on the take.
Okay. It looks like people are busy. So here. Okay. Yeah. So it looks like this is because in your clinic, this is defined as an exit event rather than an entry point. So yeah, so it should be enter. Yeah.
That would.
Yeah. Okay. Yep. Oh, the destination clinic is what sort of variable? What's the type? Clinic. It's a clinic. Yeah. Okay. Are people ready to run this? Are you ready to run it? Okay, what are you going to see? Okay, so ladies and gentlemen, what's going on here? Folks, what's going on? Let's go down to clinic 0. What do you see before you? Well, this is a report that includes a variety of information about the functioning of this clinic. One very important component is the resource utilization scene associated with the healthcare workers. But another thing is how many individuals have gone down different paths of this, so the different pathways down. Now this is particularly simple. We're going to add a bulking transition as the final components. But one thing you'll find is, folks, what fraction of people are, how many people thus far have suffered from treatment failures? 3 people out of a total of how many? 93 have suffered from treatment failures. Okay. Now we could go look at Clinic 1, which is considerably more busy. Clinic 2. Okay. Okay, that's good. So, ladies and gentlemen, who has a question? Okay, great. Now I'd like to challenge you folks. Can you, and I'll be with you in just a sec, can you folks add, so this is a challenge for you, I'll be following you on this in just a minute, but I'd like you, this point here, this rightmost point there, is a point of bulking, where bulking can occur. In other words, you can leave this clinic if you are not serviced within a certain amount of time. Okay? And if you go and you look at the properties of this, one of the things that you'll find is that there's an option of bulking within this facility. You'll notice there's this timeout, and you're going to do enable exit on timeout. Okay? And for the timeout, I'd like you to set a timeout of a triangular distribution, once again, and the triangular distribution should be 60, 90, and 120 minutes. 60, 90, 120. Okay? There'll be a timeout. And I want you to think, you have to hitch something up to that. Where should it go elsewhere in this process?
So in Australian hospitals, this is called D&W, did not wait.
Did not wait. Yeah. So you're going to want to do a triangular distribution, triangular, and 30. Oh, sorry, 60, 90, and 120. And then you have to be careful with the triangular distribution to specify proper units. Minutes. Yeah. Yeah. Okay, so can I have a suggestion I might know. So in this thing here, you have here, so when you enter this state, you have to present good care. In other words, you need to go enter that clinic. So you need to go to that destination clinic. Yes, this is correct. This is correct. You got that. So this is good. You need to go, and at this point, you need to do, you have to tell this destination clinic dot Walkins, this walk-in area, maybe you could fill that out. Well, it's actually, I think, with a capital I, but maybe you can do control space, whatever. Okay, you did a lowercase. Okay, Walkins dot take. And this, that's me. Okay? Yeah, that's it. That's all. Yeah. What's that? Sorry. Okay. Who else needs help here? Yeah. Oh, okay. So don't fill anything in. Great question. Don't fill anything in for the canceled units, but you will need to take a transition and connect it from this point here to some other point. And I want you to think, to where will that go? This is someone who's not been assigned a healthcare worker. They've balked because they did not wait to be assigned a healthcare worker. To where would they need to go? To departure directly. So you're going to take a thing, maybe you want to copy one of these bent ones already, and you're going to stretch it over from here to here to departures. Okay? And that's going to reflect the fact that people refuse to wait sometimes, even for the care of conferred. Yeah.
Oh, yeah, that would be not good.
Yeah, yeah. So it's possible that that's too long in other words, it's too long a threshold for them to leave. Why don't you try it? It's a good question, because it's the first time I've tried that number. So why don't you try a much shorter one, like they leave after 10, 15 minutes or what have you. Make it, Sankalp, make it, yeah, 10, 15, 20. Yeah. Okay. So folks, I'm going to undertake this bulking. Okay. So tell me what you find, Sankalp. Eh? Okay, so for assign healthcare worker, I am going to enable timeout, and this is going to be based on triangular distribution. And I'm going to actually do it with a smaller one because Sankalp was reporting no one's in fact bulking. So I do it 10, 15, and, well, I'll say half an hour. 10, 20, and half an, well, 10, 20, and 45. There. It won't be symmetric, but that's fine. And this is going to be in minutes. Okay?
If you get 10, 15, 20, then a couple of people leave.
A couple of people leave. Okay? Okay, and so this is the first step. So Sankalp found that those times were too long to lead to bulking, given the size of the population. And instead, you need to have shorter times, which is indeed what I had written down, but I didn't. It seemed very unrealistically short. So. Okay, and there we go. I just connected that to this, and now I'm going to run it. And I'm doing it with 10, the bulking time of a bulking distribution associated with 10, 20, and 45. So some people are willing to wait a long time, but most are somewhat impatient. And I'm going to run this. Come on. Okay. And here we go. Okay. Let's go take a look. Okay, here's clinic 0. It's processed 100 people. And it looks like 2 people went out via this other path. 2 people left via bulking in mine, and none for this clinic. Okay. Okay, now Sankalp had asked, why is it that this simulation finishes? So where would you go to determine when a simulation finishes? Under what conditions? You go to the experiment, and you set the time area of the experiment. So the model time, for example, and you can say, okay, whether to, now in this case, everyone is, okay, this is interesting. It's set to never, so that must mean that no more events are occurring. So and it's probably because the guard is true. So I'm suspecting, are they being cured? Are they turning green in yours? They're red. So that means they're still ill. Okay, they're red because if they're red, they're never going to present for care again. They're going to have been sent home. So why are they red still? So there must be something missing here. Sorry? What time is it finishing? I think it's going essentially to time infinity because there's no more events to be handled. It's going to time infinity because there's no more events, because it knows it's impossible. So there's some key thing that's not occurring. They are not getting properly cured.
Well, it's consistent with the headline saying that eventually the health system will fail.
Well, okay, but here we should be able to print something out. So the question is, are they getting cured here? So let's go through a little debugging exercise here. Okay, first of all, are they getting back to this healthy state? I was cured if they went down this path. Let's go see. Ready? Okay, so let's run this. Okay, trace ln. Oh, trace ln. There we go. Okay, so here we go. Okay, and is anyone getting cured? Yes, people are getting cured. Okay, so what is happening? Why are they all ill? Do they get what? They're healthy initially.
So they're initially healthy, they become ill.
They're initially healthy.
They randomly get picked.
They become ill. They go and present for care. They, when they're cured, they transition across here, and they're becoming healthy again. That's the strange thing, because we are assigning color equals green here.
They're still ill, they need to go back to clinic.
Sorry?
Don't they need to go back to clinic if they're ill?
If they're ill, but they are clearly getting cured. I mean, they're crossing this transition.
Yeah, but at some point they're still getting
some
cured.
are, but others are getting sent home.
Okay, hold on for a second. I am wondering, is this associated just with the bulking? I think it's a bulking thing. I think it's so busy no one goes there anymore.
Even before you put your bulking thing, it was happening.
It used to be.
Nate,
Yes.
maybe when a person becoming you, then you should go to not seeking,
Okay.
seeking care. I think the link between the two. Because not seeking care, everybody starts from not seeking care.
Okay.
It's not like those who are ill and not seeking care. It's like everybody's not seeking
No, but even if they're not seeking care, when they come to not seeking care, they transition at a rate of 0.05 per day to
Yeah, but
find a clinic and then
those
move.
should be a small percentage of the instead
So-
of
Yeah, I don't see why this is doing it, but I'm gonna find this. So I think they are correctly getting processed here. I think they are transitioning back, having been cured because they're clearly going down here. Why they are appearing constantly healthy. Okay, let's do a sanity check. Let's go see, is it a color issue or is it an issue with their true state? How would we investigate that? This is a great little exercise in debugging. How would we could actually go down to the level of a person in the navigation. Let's go look at the population. They are ill. Okay, but they're not seeking care. Yeah, but I checked that. They're actually going down this transition, and it is setting them to green as a result.
So if we set a variable in there saying that counts how many times they went in through that, we know whether they're actually going through the loop a second time.
This is true. Yeah, we could do that. I'm wondering if they're.
If you remove your guard and have
Do we need to change the color of the transition?
No, the color is being changed. So it's being changed here when you enter this action. This is really interesting, man.
Only 5% of those who are you.
Nate, if I remove your transition, if I remove your
Yeah,
guard,
yeah.
then it's working fine. It never stops.
I know what it is.
5%.
I know what it is. Okay, got it. Okay, that shouldn't be needed, but I had notes saying it may be needed. Darn it. Okay, great. This is terrific. So this is what we have to do. I'm sorry to tell you, but this is what we have to do. Say it won't, say it ain't so. Okay, we need with a rate of once a day. Actually, we don't just need that. We need to reevaluate the guards. So we need them to actually come out of here and actually come back in. That's what we need. We need them to re-examine the guard. Basically, if the guard is false when they come in, they won't be re-examining it right now. They won't question the guard. So they need to come out and go back in once a day. That's, I say it ain't so, but watch this. You ready? You ready? Okay, watch it.
Yes, no problem. So what did we do?
Okay. Okay. This is a sad truth. Can I tell you the sad truth? So this is what's needed. I'm sorry to tell you, but it is true. And actually, maybe Anatoly could comment on why this is needed, because I thought with state charts, this was actually automatically done, but the evidence suggests not. So the deal is, we have a guard associated with this transition. This guard is contingent upon being in this state ill, okay? Now, what was going on seemed clear. What was going on is that these folks were ill, but these folks were healthy. They left care. They went to not seeking care. While they were in that state, they became ill. However, when they had entered not seeking care, they were in fact healthy. So this guard was false. And as a result, this rate was not being calculated again. And even though they transitioned to an ill state, this rate was still blocked by them, by the fact that it said there's a guard on them that was contingent on them being ill. When they had entered here, that guard was false and it didn't re-examine it. So I just put in this re-examination here that once a day, they enter and leave that state again. And what that does is it has the effect of getting them to sort of enter the state. And guess what happens when it enters the state? It recalculates this guard. And so once a day, their health status is reconsidered and they may be eligible again for transiting to care.
So this right. Although you use rate for
Yeah.
this, this is actually a rate for the whole population, right? So this rate is actually transformed to a timeout, which is 1 over rate.
Well, but it's probabilistic, and so, you know, what I wanted is, some people would present early for care once they were ill, some people would present long.
But the transition is scheduled only once. And
Correct,
it's
exactly.
recalculated
Exactly.
only
If they leave and come back. Yeah.
right.
Yeah. Yeah. So one possibility will be to make this a conditional transition based on being ill. They would come into a state, and once they were in that state, then they could transition with a rate transition. Otherwise, this is another solution to sort of re-examine it.
So that one needs to be at a rate of once a day or a timer of once a day, anything just to get them out regularly.
Right.
Okay.
Right.
So I would say that
Yeah.
there could be logical enhancement of this state
Right.
chart with additional state.
Right.
Ill but not seeking
Precisely.
care.
Precisely.
And there should be a conditional
Yeah. Yeah.
transition
Precisely.
there
Yeah.
and then a
Yep.
timeout
Yeah.
transition.
Yeah. That's what I just
That
suggested.
should work.
That should work fine. Yeah. Yeah. Okay. So, folks, that solves the issue. Once you have that, you should be able to observe this sort of long term, in terms of watching the flow of patients through this clinic. And you'll notice there is some bulking going on here, as a result of the waiting times involved. Now, yeah.
Food's hot today.
Okay.
Maybe 4 minutes warning.
Yeah, sure. I think we're essentially done.
Okay.
But I like this idea of this other transition, or this other state that's an intermediate state. So this would be not seeking care, and then here this would be ill but not seeking care. And actually, this one would be called healthy not seeking care. And this would be a conditional transition, conditional on this.
But would the condition not just be tested once? Again, same thing?
No, I think with state charts, it's actually quite good about knowing to check it when the other state charts change states.
Yeah. The condition is checked every time something changed in the model.
Yeah. I just, yeah.
So
Okay.
you should be careful about that, because having too much conditional transitions results.
Slow down.
Yeah, in a slowdown.
Yeah. So that's good. And boom. Yeah, thanks a lot, Anatoly. I really appreciate that. And we'll have this transition, which needn't now have a guard. This transition that results requires no guard. It's because there's already been a gating that went on here based on this condition. This transition here is simply a rate transition now without a guard. Yeah.
I must admit, I think we've basically gone away from the separation of concerns here. So we've actually added healthy and ill and combined.
This is true.
Yeah.
So I prefer the reconsider. My view would say is
Yeah.
you're actually just decided or not seeking care.
That's
and
true.
there's a decision, and then you reconsider daily, which is quite.
Quite plausible.
Right.
And then so you're in a So
Yeah.
you might be in a wait
Yeah.
state rather than
Right.
healthy, not ill, not. Yeah.
Right.
You're just waiting. So it's just about your decision, because you could be healthy and decide, will I go to the doctor today for a checkup?
Yeah, so actually probably the most logical one could be reconsider not every day, but again based on some rate.
Right.
Reconsider rate, and then
Yeah.
it should work.
And how worried you are, how anxious you are.
Mm-hmm.
Yeah, that, I think, so I like
Yeah.
The resource pool percentage, what does that mean, the 10%?
10% busy.
10% busy?
10% of the
For a period
of the time they're busy.
It's underutilized, and then you look at the population, there are lots of red.
You really,
so it's
all you're doing is.
Well, I think now,
Care pathway, clinical pathway.
yeah, but a lot of the reasons they're red is because they haven't presented for care. They're ill, but they haven't yet. So remember, there's a delay here where in the model between when they, let me stop this. There's a delay here between when they become ill and when they seek care. This is captured in this. So in other words, there's a 20-day delay where they're going to be ill. Even they're not constrained in any way by the clinic yet, but they're simply not yet presenting for care, and that leads them to stay red for a while. But when they go in for clinic, they're getting cured pretty quickly. So I guess as a final thing, folks, thanks a ton. Really appreciate that. That's great. And I do think it's maybe worth talking about. I don't know if it's possible to get guards recalculated automatically when you change states, but it would change the semantics. So yeah. Why don't we try this with a large population, and then that'll be the last thing we do here before lunch. Okay? So let's copy this. And now let's impose a large population. Okay. And this will be a large population. Let's make it a population size of, say, 5 times larger, 6,000, with these 3 clinics. What do you think will happen as a result? Lots of bulking. Yeah, do not wait. DNWs in large amount. No, this is, come on. Come on. Okay, there it is. So we have a population with, that's larger, the same number of households, so the size of the population is not clear. But if you look at the statistics here, we have, excuse me, this is not the large population. This was this, okay, I thought I ran the large one, but it was just the regular simulation. No, it evidently was, okay, fine. This is the, this is the, well, you can't tell, but is it 6,000? Oh yeah, it was, the population size was 6,000 there. Yep, 6,000. Okay, and so here, if you go down and look at the clinics, they have higher demand for them, and proportionally speaking, I believe that this is going to be a larger fraction. I mean, it looks like roughly to me about 5% of the folks are now balking, are do not waits, because of the greater contention for the services. And of course, another thing you could do is you could look at the regular population size with fewer clinics, right? So here we have 10% utilization that Xiaowen had noted, right? 10% utilization with the clinics here, although I think it will vary clinic to clinic. Here's clinic 0, the first clinic. Here's clinic 1, which exhibits 18% resource utilization, in clinic 2, 3%. Where do you think clinic 1 is? That's that second clinic. It's probably this one down here.
That's the question. So we'll pop over. It doesn't show this is 1. So
When you, sorry?
which one is 1?
Yeah, it used to be with AnyLog 6 that it would move this icon to where it was on the screen, but that's been deprecated. So I don't know if there's any quick way to sort of know which is which. What you could do is put in an on-click event and click on it, and it would say, I am number 3 or something like that.
Or you can add a text over the icon
Exactly.
saying
Yeah.
get index
Yeah.
as a text. So it will display the index of this clinic in clinics
Exactly.
population.
Exactly. So, so that's good, and you know, we could form another one here, which has a single experiment with the standard values, but here single clinic default population size, right? So we could examine what are the utilization rates and what are the balking rates if we had a normal population size but only a single clinic. What would we expect to see? But more than this, folks, and I want to bring home this message from this example. What's special about this example is that we tied this clinic, on the one hand, to this population health depiction. So, you know, while we could look at things like utilization rates, and while we could look at things like time to service, and while we could look at things that focus on the clinic side, the balking, what's much more significant is we could look at measures like on prevalence, the prevalence of illness in the population. That's a more fundamental quantity related to the population health, and that's what this model would allow us to do. It would allow us to take a look, you know, in our population at how the burden of illness, on the one hand, varied or covaried with the balance between the population size and the number of clinics, right? So it'd be a very easy thing to do, and you know, the clear thing to do is you could add a statistic, you know, count ill, right? And we would count up the number of people based on what? This would be item dot health state chart dot is state active what? Person dot ill, for example. And we could then look at the graph of that over time. Right? Yeah. Okay, any question? Yeah, you could, on a per person basis, when they present in clinic and when they leave, you could record the time. So by the state chart? Yeah, you could do it in the state chart too. That'll be another possibility. Sure, sure. Okay, food has arrived. Great. Okay, so we're gonna break now. Yes.
Two of us are heading back to Queensland.
Oh, okay.
Towards the cyclone.
Oh gosh, is there a
I'm
cyclone?
hoping to get home before it floods. Yeah.
Is it going to be hitting them the next day?
It's just arrived in northern Queensland.
Really?
It's coming south to Brisbane.
Oh man, I'm sorry to hear about that.
But thanks very much for the session.
Oh.
It's been fantastic. Really
Fantastic. I'm delighted it's offered some value.
Yeah, we'll be watching your
Yeah.
YouTube stuff and your
Well, safe travels.
Yes,
It's the
thank
important
you.
thing.
When
Okay.
are you heading home?
On Sunday.
Sunday.
Yeah. 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 Yeah.
Yeah, I checked this
Yeah.
thing with triangular
Yeah.
distribution,
Yeah.
and it works either way, whether you put mode